Homework 5.1, System of Equations, Video 2. Homework due Friday, May 29th at 11:59 p.m. This video and the following video will be associated with homework questions 1 through 4. Solving 2x2 linear systems by substitution. Full disclosure, I know of at least a half dozen ways to solve a 2x2 system. I'm pretty sure it's at least 6. I haven't counted them lately. I'm not going to show you all of them. Some of them are beyond what you could comprehend at this stage of the game. Some of them I could show you. Some of them I might just mention. For example, graphing. We could graph both of these and see where they intersect. The intersection would represent the solution. I would not do that unless you use technology, because if you do it by hand, everything has to be dead on perfect, and you better hope that the lines intersect at integers. So with technology, and I invite you to try this in Desmos. Get in Desmos, type this, click where the lines cross, and it'll say, here's the solution. But if the solution is not a whole number, then have fun, because it may be a really ugly decimal. But I'm going to show you techniques for solving 2x2 systems manually. I'm going to show you 2 techniques, and one of them is called substitution. But before I show you that technique, let me kind of explain what our goal is. Well, what's the goal anytime you solve something? You want to know what x equals, or in this case, you want to know what x equals, and you want to know what y equals. So if you think about it, we're looking for an ordered pair solution. So how are we going to find it? Well, normal equation solving protocol is to get a letter by itself, but we have a problem. Pick an equation. Let's say you pick the first equation. Pick a letter. Let's say you pick the x. If I solve for this by getting it by itself, then this y would be on the other side when I'm done, and I won't know what x equals except a bunch of stuff with y in it. And the same is true for any of the letters. The biggest obstacle right now is that I've got too many letters at once. This equation has 2 letters, this equation has 2 letters. So no matter which variable I pick and solve for, the other variable is in the way, preventing me from my goal. So how do we overcome that? Well, in order to overcome that, we need to get rid of a letter in either equation. Maybe we need to get rid of the x in the top equation, or get rid of the y in the bottom equation. But how can you just arbitrarily get rid of a letter? Well, one thing you can do is replace it with something that it equals. So here's our strategy. Let's find one letter to get by itself. That'll tell us what it equals. Then can we use that as a substitution in the other equation? I think that's a fine idea. How to solve a 2x2 system by substitution. I'm going to lay out a plan that will always work. Sometimes it gets a little ugly, but it will get the job done. If we're going to do a substitution, we need a substitution, and in order to get one, we need to solve for a variable. So on your first move, you have some decisions to make. Solve either equation for either variable. Or another way of looking at it is pick any one of the letters up there and get it by itself. Now sometimes some choices are better than others, but one of these 4 letters is going to be easiest to get by itself. Which one is it? The top x, the top y, the bottom x, or the bottom y? The easiest variable to isolate right now is the bottom y. Why? What's its coefficient? 1. The other coefficients are not 1. So if I have to solve for any other letter, my last move is going to be divide. So for example, if I solve for the top x, my last move is to divide everything by 2. And while the 4 will divide by 2, the 3 won't, I'll create a fraction. If I solve for this x, I'll have to divide everything by 5. That won't, that will create a fraction. So if you can pick a letter that doesn't involve any dividing, or at the worst, dividing by 1 or -1, that's the letter to go for. So I'm going to start this substitution approach by solving for this y. And it's actually pretty easy. All I have to do is add the 5x to the other side, and we'll get y equals 5x plus 7. I'm going to put a box around that and call this my substitution. And I should actually make a comment on step 1. This equation is now your substitution. And we've used substitution before when we were solving quadratic-like equations. But the premise of a substitution is to replace something with something else. Now, when we did substitution in quadratic-like equations, we replaced a larger expression with a single letter. Here we're going to do the opposite. We're going to replace a single letter with a larger expression. I now know that y equals 5x plus 7, which means anywhere I see a y, I can replace it with 5x plus 7. Guess what? I see a y here. Second move. Use the substitution. Use the substitution to rename a variable in the other equation. We used one equation to create the substitution. Now we're going to implement it in the other equation. Now, just as a warning, use parentheses when you make the substitution. So, now let's go to the other equation. Remember, we chose one of them to serve us a substitution. Now we need to go to the other equation, which is 2x plus 3y equals 4. But let me show you what I would recommend. As you're writing it, don't write the letter that you just solved for in the previous step. I just solved for y. Instead of writing that letter, write some empty parentheses. Because that's where the y used to be, and guess what I'm going to put in its place? 5x plus 7. Scoot that over. Oops, that's not equal to 7, it's equal to 4. 2x plus 3y equals 4, yeah. So use the substitution to rename a variable in the other equation, use parentheses. And the reason you use parentheses, if the letter you took out had a number in front of it, it needs to get distributed. Without the parentheses, you might forget to do that. Now, that looks like it makes things worse, but it makes things tons better, and here's why. We started out with two equations with two variables. And we couldn't solve for either because each one was in the other one's way. But where are we now? One equation, one variable. We've just reduced this from a 2x2 system to a 1x1 system, and we can solve that. Step 3, solve for the remaining variable. Solve for the remaining variable. Now you're going to have to do a little bit of hand waving and combining of like terms, but that can't be a big deal at this point. Oh no, I have to distribute. Yeah, and 2x plus 15x plus 21 equals 4. Oh no, I have like terms. Again, so 2x plus 15x is 17x. We still have plus 21 equals 4. Now this is just a simple linear equation. It's a pretty straight path to the end. Finish isolating the x. Subtract 21 from both sides. 17x equals 4 minus 21 is negative 17. That's good because my next move is to divide by 17. And 16 out of 17 times, that turns out bad. In this case, it doesn't. Divide both sides by 17 and we get x equals negative 1. Hooray! We solved for x. Don't get too happy. How many variables did we have? 2. X and y. We only know what x equals. We still need to know what y equals. So we're not done yet, but we're almost there. So how are we going to figure out what y equals? Well, wait a minute. Didn't we have something that already says y equals? Isn't it in red, in a red rectangle? Yeah, the substitution says, I'll tell you what y equals if you tell me what x equals. I know what x equals. So for your fourth and final step, use the substitution to solve for the other variable. your substitution takes a variable out of the picture temporarily so that you can solve for the second one. And once you solve for it, use the substitution to pick up what you don't know. Now I need to know what y equals. According to the substitution, y equals 5x plus 7. So y equals 5 times negative 1 plus 7. So y equals negative 5 plus 7. And y equals 2. Let me see if the homework one's in ordered pair. It does. It says type in ordered pair. So if this were a homework question, you would type in your answer as parentheses, negative 1 comma 2, as usual, x first and then y second. So the premise behind substitution is, I think, fairly intuitive. Our biggest obstacle is too many letters at once. By solving one equation for one letter, we can replace it in the other equation and get it down to one letter. In this case, we got it down to x's. Solve to get half the answer, go back to the substitution to pick up the other half of the answer. When you're selecting your substitution, I would choose the letter that has no coefficient. It's easiest to solve for. Of course, that raises a question. What if they all have coefficients? Well, in the next video, I'll illustrate that even in that case, it still gets the job done.